Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Enabling Seamless Connectivity with NXP USB Type-C Connector Solutions, brought to you by NXP Semiconductors, Tech Online, and broadcast by UBM. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, this webcast contains audience polling. The polling question will appear in the slide presentation window. Please complete the poll when they appear, and then click the Submit Answer button located on the polling slide window. Thank you in advance for your participation. You can also participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the Submit button. Please note that we'll try to get to every question that we can in the time that we have left today, but if we do not get to your question, someone will get back to you via email. Also at this time, we recommend that you disable your computer's pop-up blockers. This will allow the slides to advance automatically throughout the event. In addition, you can download a copy of the slides by clicking on the Additional Resources button located below the presentation window. And if you're experiencing any technical problems, please visit our webinar help guide by clicking on the help link below the presentation window. You can also contact our technical support helpline, which is located in the webinar help guide. And now on to the presentation. Enabling Seamless Connectivity with NXP USB Type-C Connector Solutions. Discussing today's topic is Ravi S. Shah. Ravi is currently an applications engineer and regional marketing team member at NXP Semiconductors. In this role, he is responsible for supporting the customer and marketing activities for NXP's interface and power products portfolio. His interest areas are mobile, computing, networking, storage, and consumer products. Prior to NXP, Ravi was at Cypress Semiconductors, where he worked on high-speed serial interfaces, broadcast video solutions, and power line communication. Ravi holds an MSEE from the University of Southern California. Welcome, Ravi. I'll now turn things over to you to get us started. Ravi?
Thank you, Chris, and hello, everyone. So USB Type-C technology has quickly evolved and gained traction throughout the industry. And one of the key challenges that comes with USB Type-C is that it requires astute design because of several possible configurations that it allows. So in today's webinar, we are going to look at, just go over the overview of the Type-C standard. We'll look at how the ecosystem is going around Type-C, where is the market adoption happening for Type-C, and also look at, most importantly, how do you design a system using a USB Type-C connector, and talk about NXP solutions as well. USB Type-C offers several benefits like size. The connector itself, offers several benefits like size, ease of use, future scalability, backward compatibility, and so on. So it is really an all-in-one connector that can plug in either way. It can support power delivery up to 100 watts bidirectional. It can handle up to 20 gigabit per second data transfers in a very compact, reliable form factor. It is also backward compatible, and it can accommodate both active and passive cable options. So we can already see this connector offers a lot of flexibility and the potential to implement a lot of different features in your system. So before I jump into more details, I think we'll go to a poll question.
All right, thank you, Ravi. And our first polling question for you is, how familiar are you with USB Type-C standard and technology? Here your answers can be very new to this technology and standard, B, moderately familiar, or C, in-depth knowledge. Just click on the radio button next to the answer that's appropriate for you, and then click the Submit Answer button. We'll give you a few moments to go ahead and input your selections. Again, our question, how familiar are you with USB Type-C standard and technology? Very new to this technology and standard, moderately familiar, or in-depth knowledge. And we'll give you just a few moments to go ahead and input your answers. We will have two polling questions. This is the first of two, and we encourage you to respond as it will help us to drive the rest of the webinar. And we'll take a look at the results in just a moment here. Okay, so let's go ahead now and take a look at our results. It looks like 45.4% said very new to this technology and standard, 51.5% said moderately familiar, and 3% said they have an in-depth knowledge. So, Robbie, your thoughts on those results?
Thank you for the poll results, Chris. And this just shows, as I mentioned early on, how new this technology is, and it has rapidly evolved and generating a lot of strong interest, across the industry, across various, market segments. So with this in mind, what I'm going to do is I'm going to go through an overview of the USB Type-C standard, give some technical background, and then jump into the solutions, which will be helpful for everyone. So let's look at, what are the capabilities of the USB Type-C standard and, what all is included. So to make it easy, let's just look at three different things. So there is a USB Type-C standard defined by USB-IF. It allows the pass of, USB 2.0 signals and USB 3.1 signals, which includes, USB 3.1 Gen 1, which is 5 gigabit per second, and Gen 2, which is 10 gigabit per second. And by default, it allows up to 15 watts of power transfer or power delivery, or charge through 15 watts through, 5 volt 3 amps. So the max you can do through the Type-C connector is 5 volt 3 amps. Now there is another standard that goes along with it, which is known as power delivery standard, which is also gaining a lot of traction. And what that does is it adds the ability to do scalable power charging and increase the capability of your Type-C port up to 100 watts. And then there is yet another standard that kind of goes along with the power delivery standard. It is known as alternate mode standard. And what this standard does or allows is the ability to support, DisplayPort video over USB Type-C. So as the name suggests, the best way to look at it is an alternate mode, which means you're going into a mode other than USB. And here, for example, through DisplayPort, now you have the ability to support even video through this particular standard. One thing to remember is that the alternate mode spec is closely tied to the power delivery spec because they kind of share the same messaging architecture, and this will get more clear as we go along in today's session. But USB PD implementation is required if you want to support alternate mode. So just to make it clear, what I mean by this is if you have a system that requires, say, less than 15 watts of power, you do not need the ability to go up to 100 watts or even more than 15 watts. However, you do want to support the ability to send video data over your Type-C connector, then you still need to support the power delivery standard and the alternate mode standard in terms of your system design and the ability to interpret the power delivery messages. So again, to recap, power delivery specification extends the capability of the Type-C to 100 watts, and it also makes your charge flow scalable, which means you get the ability to negotiate a particular profile anywhere within the 100 watt ceiling, through 20 volt 5 amps. So you can have a system, for example, just making up a number, you can have a 15 volt 3 amp system or 12 volt 3 amp system, so on and so forth, anything under the 20 volt 5 amp ceiling. Hence, to make it clear, there are various power profiles defined in the specification, which I have mentioned here. And these, as you can see, are very popular nodes applicable to different types of devices that we use. For example, 5 volt 2 amps, which is about 10 watts, is for, our mobile portable devices. About 30 to 45 watts is good enough for a high-end tablet type of device, or going up to notebook and even workstations that can support up to 100 watts, which is obviously a lot of power. Again, one thing to remember here is that these power profiles are only guidelines, and a particular design does not need to stick to one of these discrete profiles, which means you can always have a system, say, for example, again, making up a number, you can have a system that is not supporting a voltage that I have mentioned here, which is not 5 volt, 12 volts, or 20 volts, and again, any particular current under 5 amps, you should still be able to support it over your Type-C design. So with this background on the spec, let's also look at the details of alternate mode. So alternate mode, as I mentioned earlier, allows you to pass signals other than USB or along with USB, but different than USB through the Type-C connector. So under the alternate mode spec, now for example, you can send, you have the ability to send DisplayPort video data through your Type-C connector, through which you can now connect to video capable downstream accessories or devices that require video data. So with this, you can see that truly through this connector, you have the ability to send your USB 2.0 data. You have the ability to send the high-speed USB 3.1 data, and at the same time also be able to send some sort of video data through DisplayPort along with the power, all at the same time through this one single connector. So it is truly, it opens up a lot of different possibilities. And let's look at the pinout of the Type-C connector to see how this single connector allows you to do this. So as you can see in this connector, it's a 28-pin connector, and right in the center you see your D plus D minus lanes, which we all are familiar with, from our USB 2.0 days. So those are the lanes dedicated for USB 2.0 traffic, and then in total you see 4 pairs of high-speed differential channels, 2 on each side, which are TX, RX differential 1 and 2, 2 on each side. Those are the high-speed lanes capable of taking 20 gigabit per second data traffic through them. So through those pins, you can send your USB 3 or USB 3.1 signals, and or your alternate mode signals would also pass through the same pins. You also see the VBus pins, which is your main power line, your voltage line, which is where you're going to see the main voltage and current for your bidirectional communication. You also see 2 pins called CC1 and CC2. So these are the pins. CC stands for configuration channel, and so these are the pins used to exchange messaging on both the sides and establish who is going to be the provider, who is going to be the consumer. So those type of things will be resolved using this configuration pin. So at a high level, you can see how there is a provision or there is a pin the pin or pins dedicated to do all these different types of data transfer that we just talked about. And one last thing, which is very important from a consumer standpoint, that this connector is flippable. So you should be able to plug it in either way, and the system should still work. So I just want to show you what would happen when you flip your plug. So the top view that I have shown here is a receptacle view, but the bottom view is a plug view, which means if you have a plug plugging into a receptacle, if I flip that, you can see the most important thing to note here is when a plug gets flipped, the high-speed lanes are going to get swapped. So your TX1 and RX1 pair now just went to the other side, and similarly the TX2, RX2 pair went to the previous side. So what this tells us right away is that from a system design standpoint, we will need some data switches in the path to be able to support this flippability of the connector, so that no matter how the plug gets plugged in, we are able to identify which data is on which lane and route that pins to the appropriate pins on the chipset or whatever host controller that we are using. So hopefully this gives you a nice picture of how we can do all these different things at the same time. From a power standpoint, let's just look at the progression that we have seen across the USB standards. So we all know, USB 2.0 supported, 5 volts, 500 milliamps, and then USB 3 or 3.1 went up to 5 volt, 900 milliamps, and now we can go up to 100 watts through 20 volt 5 amps if we support power delivery. And if you just adopt the Type-C standard without the power delivery, you can still support up to 15 watts through 5 volt and 3 amps. So this just gives you, where different power profiles sit and how USB has evolved in terms of its power capability as well. So let's look at the CC channels that we talked about. There are 2 pins, CC1 and 2, and as I mentioned, they are used for attach-detach detection, also determining the plug orientation. So now we saw that the CC1 and CC2 pins are not quite symmetrical. So if you want to identify which way your plug orientation is when it gets plugged in, we can do that using the CC pins and then use that information to drive our data switches so that we can route our high-speed path appropriately. CC pins also help us in determining our initial port roles, which means if you plug two different devices over Type-C, we need a mechanism to determine which side is going to be the power provider and which side is going to be the power consumer. And as the name suggests below the diagram here, the side that becomes a power provider is typically known as a downstream facing port, and the side that becomes a power consumer is known as UFP, or an upstream facing port. Also, one thing to note, the DFP has pull-ups on its side on the CC pins, while the UFP has pull-downs on its side on the CC pins. So essentially, the side that will become a power provider will have a pull-up on the CC lines, and the side that becomes a power receiver will have a pull-down resistor on its CC line. Now, when you are supporting power delivery, so not only Type-C, but when you do adopt the power delivery standard in your design, CC lines can also be used to modify the initial port roles, which means you can do a power role swap. You can have a provider become a consumer and a consumer become a provider. And the same pins will also be used for negotiating power contracts through a particular messaging or signaling standard as defined in the USB spec. So if you adopt power delivery from a practical standpoint, envision this. If you connect your notebook and your tablet, assuming both of them have Type-C and they both are power delivery capable, if you connect them over Type-C, you can have your notebook charge your tablet, the use case that we are familiar with, but your tablet can potentially charge your notebook as well, because now you can have bidirectional data transfer, and you can really see the wide array of use cases that can become possible with such bidirectional power transfer that can go much higher than 15 watts. Lastly, the CC pins and the spec also allows the ability to send structured messages, so something called VDMs, which is called vendor-defined messaging, which means if I'm making my own system and I want to communicate something downstream, which is very specific to my own implementation, and if both devices that I'm talking to or I'm connecting are my own devices, then they will be able to understand my own proprietary messages. So again, at a high level, CC pins not only help us configure the system, but in alternate mode and power delivery cases, they also help us in sending the PD and alternate mode messages between the two sides. So with that background, hopefully, now you have a kind of a very nice picture of, what the USB Type-C spec is, what is power delivery spec and alternate mode spec, and how they all tie in to have this one connector where we can send USB 2 data, again, USB 3.1 data, and video data along with power at the same time. So with this background, let's look at the ecosystem and where Type-C connector is being adopted today. So as you all must be aware, the first wave of adoption is definitely happening in the consumer world. We have a whole array of consumer devices that can adopt USB Type-C. You all would have seen a couple of products out there in the market today that already have a USB Type-C port. And then eventually the vision is that everything that gets connected to each other that everyday consumers use will move to USB Type-C port as well. Another key thing to note is the chargers that we use for our products, consumer products, will also have a very good reason to move to USB Type-C, supporting power delivery, because now you can have this single connector support up to 100 watts, and you can have a standard, USB standard charger that can charge everything pretty much if you are supporting power delivery and if it supports all the right profiles. So there is a lot of work going on this side as well, but you can see how simplified the consumer ecosystem becomes once you have everything just connected over a single cable and a single connector. Next, it's very easy to imagine once you have all the consumer devices adopting Type-C, a whole another set of devices, potentially like our set-top boxes, our peripherals that we use, storage devices, game controllers, all of them also have an incentive to move to USB Type-C device because we all want to be compatible, and give the users, the end customers, that flexibility and ease of use. Again, going back to what devices are available in the market, there are a couple of notebooks out there today that have already USB Type-C ports on it, and they're available in the market today that you can go purchase today. Another thing to note is with USB Type-C connector, there is a big use case for the dongles because now you can have this one connector which can be outputting USB data, it could be outputting video data, and power as well. And you may want to connect it to different downstream accessories. So if I connect my Type-C connector to, say, an HDMI or a VGA or some sort of video monitor, then I'll need a dongle which will take my DisplayPort data in a way and connect it to the appropriate standard downstream. So that's whole another area that is very interesting, and it opens up the possibilities of doing a lot of dongle designs around the Type-C ecosystem. So with that, it's time for another poll question.
All right, thank you, Robbie. Our next polling question for you, and this is the final one for the day. What type of applications are you designing around USB Type-C? Your answers here can be consumer devices, as in phones, tablets, etc., computing accessories, automotive applications, industrial or medical devices. And just go ahead and click next to the radio button that's appropriate for you, and we'll take a look at those results momentarily. Again, what type of applications are you designing around USB Type-C? Consumer devices such as phones and tablets, computing accessories, automotive applications, or industrial and or medical devices. So let's go ahead and have you submit your answers, and we will have one more poll, and that's just a survey for you at the end of the webinar. We do encourage you to participate in that as it will help us to improve our future webinars. But we're going to go ahead and take a look now at our results, so let's do that. And it looks like 40% chose consumer devices, 20% computing accessories, 11.4 automotive applications, and 28.5 industrial or medical devices. Robbie, your thoughts on those results?
Thanks, Chris, again for running the poll, and this is very nice. It just gives you an idea of how ubiquitous the Type-C connector standard is evolving into. Because it's not focused only on one kind of industry, but this is what I was hoping to see, that it is being adopted across the board, not only into the say the phones and notebooks, so as to say the consumer devices, but also in automotive and industrial / medical applications. So this is great. Thanks, Chris, again. So with that information, let's move on now into the system solution. So we got an overview of the Type-C standard, we saw the capabilities, we got an idea of how the market is adopting it, what are the different vertical segments that are adopting USB Type-C connector. Now we can look into actually building a system with a Type-C connector. So with that, let's jump into that. So I'm going to build a system here that supports a Type-C connector with power delivery and alternate mode. So essentially, you can envision this as a superset, a system that can do everything, that is basically taking advantage of all possibilities that are given to us by the Type-C standard and power delivery standard. So envision the system chipset or your host controller as the block on the left that I have shown, and on the right is the Type-C connector that I have shown. So imagine that as an edge of your design, the connector itself. And I have mentioned some of the key pins on the connector. So you have your VBus pin, which is going to be your main power line. You have your VCon pin. So what happens is once a Type-C cable plugs into this receptacle, one of the CC pins is known as VCon, And that is because you're going to have 5 volts on that pin, and it is known as a connector voltage pin. So you have VBus, a 5 volt VCON pin, you have your USB 2.0 lines, you have USB 3 or 3.1 lines, as well as your sideband signal pins. So let's try to see how we will hook up our system chipset to the Type-C connector to explore all these different benefits of Type-C. So the very first thing you will need is something called a USB PD5. And what the USB PD5 does is it is a physical layer IC or a baseband device that handles detection and advertisement tasks according to the Type-C specification. It also carries out the BMC encoder decoder functions for the CC line communication. So what we mean by that is when this device will connect to another device which is also working over Type-C and power delivery, both sides need to be able to send and receive messages that they understand. And for that, USB, that's the reason USB has created this standard, and there is a specific messaging scheme that is used. So you need this PD5 device which follows the spec, which follows the standard, and does all the encoding, decoding as necessary as per the spec. And this, as we learned at the beginning, this PD5 will tie to the CC logic pin on the connector, and on the other side, imagine a device on the other side, it will also have a PD5 tied to its CC pin going through the cable. So now you have a mechanism where both the PD5s will be able to talk to each other. So along with PD5, you can see very logically that you will need an MCU device, which is going to be your policy manager or your system controller, or also known as PD controller, your power delivery controller. It is basically a device where you will house a fully compliant firmware, again, which is following all the details given in the spec on how to respond, what to respond, and take a system policy decision. So, for example, a very quick example I can give is, say you have 2 devices that connect to each other, and say it's a notebook and a tablet. Now, what if your tablet asks a certain profile from your notebook, saying, okay, I want 12 volt 3 amps, just as an example. Now, the notebook may or may not be in a position to give that 36 watts, and that's why you need a system policy manager which can take those policy decisions based on what the system designers have programmed in it. And then those decisions will be communicated to the other side over the PD5 device, which is essentially a physical layer device which will translate the message coming from the MCU in the PD language as per the spec. So the PD5 and MCU will work closely with each other, and they can handle all the messaging and take care of the entire standard implementation, the Type-C standard implementation. Now you can imagine, along with the PD5 and MCU, you may need some load switches on your main power line. So what are load switches? So load switches automatically isolate the connector from a faulty source or a load, and it protects it from over voltage or over current or over temperature. So we see now that the VBus line can be negotiated up to 20 volt 5 amps. And if you are making a design or a device which necessarily does not support that high a voltage or current, you want to put a load switch in your design so that by mistake, because of a faulty source or because of whatever kind of error in the connection, if your device sees, say, if your design is 5 volt and if your device sees higher than 5 volts on its bus, then you want to make sure that your device is not damaged, your design is not damaged, and that's where a use of load switch will kick in. And load switch will protect that over voltage coming in and block it. So that's why load switch is very important in this high power system design. Now, after taking care of the power path, we still got to account for the data path. And as we learned when we were discussing the pinout of the Type-C connector, that because of the flippability flippability that is supported by the Type-C connector and the ability to plug in either ways, we will need some data switches in the path which can take care of switching our high-speed data lanes. Now, depending on the use case, you may just need to switch your USB 3 signals. So if you have a design which only, say, uses a USB 3, which is you're still using USB 3.1 signals, but you are not using alternate mode, which means you don't care about video data, then you might need only a USB 3.1 switch. However, if you have a system that uses high-speed USB and some sort of video or alternate mode at the same time, then you can imagine that you will need to switch both sides, which means you need some sort of a cross-point switch, which will take both of your differential pair signals and flip it. So this shows that depending on the use case that you want to achieve with the USB Type-C, the device or the switch that you may need will change. Along with the data switch, now because of this high speed and high bandwidth signals we are talking about, you may need some signal conditioning in the path, which is essentially a redriver. So a redriver will help you boost your signal integrity and make sure your end-to-end design has good signal integrity. And finally, you will need some ESD protection and filtering for your port itself, how we use with our any other connectors that we use. So essentially, you have, to recap, you have your PV5 and MCU combination that will take care of your power delivery implementation and messaging. You have load switches for your port protection and any faulty over voltage or current protection. You have your data switches to support the flippability of the connector and support that, which is again, by spec, the USB Type-C connector is flippable. So you need to have a design that can allow the USB Type-C cable plug to be plugged in either ways. And optionally, you may need a signal conditioner, and of course, for your port, again, you will need some filtering and protection. So this is a complete solution that you would need to build to implement a Type-C connector on any system that will support power delivery and alternate mode both. Now lastly, I do want to introduce one more block here, and that is authentication. And what authentication does is it gives you the ability to identify what is plugged in on the other side. So what authentication IC does is ensures the safety of the devices connected over the Type-C connector. So for instance, it can allow the Type-C connector to authenticate the power supply that is connected on the other side, or the cable, or the accessories that are connected on the other side before it starts accepting any charge or data transfer as an added security feature to make sure that you are protecting your design. So authentication is also a very interesting technology, that can complement the Type-C design very well and make your system very secure. So all the blue blocks that you see here, are the key pieces in the Type-C design, and NXP offers solutions for all these blue blocks. The biggest value proposition of NXP solutions is that we have a full system solution, as you can see, to enable a Type-C design for any kind of application. So let's look at some offshoots, or let's look at some use cases on what are the different things possible with USB Type-C. So we just saw a system, and we designed a system that implements power delivery, that implements alternate mode, that supports USB 3.1 and everything. Now you may ask the question that, hey, I do not want to support power delivery, or my system is okay with 15 watts, and I also do not want any alternate mode. I'm not going to talk to any video devices downstream, so I don't need alternate mode, I don't need power delivery. I'm happy with 15 watts, and I would still like to use the USB 3.1 channels, the high-speed channels. So how would my system design change, right? And this shows how scalable the Type-C design is. So let's look at this system very quickly. So now instead of a PD5 and an MCU combination, you can use a simple CC logic device. Why do you need a simplified device? Because now you are not going to do any power delivery negotiation. You are not going to exchange any power delivery messages or alternate mode messaging. So NXP also offers a simplified CC logic device for applications that do want to adopt the new Type-C connector without supporting the power delivery function. So you don't need the MCU here in this case, again, because there are not much policy decisions that you need to take. It is a very fixed implementation in a way. Again, you can definitely use the load switches for your device protection from any overvoltage or overcurrent type of situation. And on the data path, because you are using USB 3.1 lanes, which are the high-speed lanes, you will need a switch. So you can use a USB 3 2-to-1 switch to account for the flippability of the Type-C plug. And optionally, based on your USB 3 signal integrity and the data path, you may need a USB 3 redriver, and again, definitely some ESD and EMI protection for filtering for your ports. So you can see that the system just got simplified, and we just used a slightly different set of devices for this more simpler application around USB Type-C. To carry this forward, imagine this. I'm just showing you the block diagram, very simple. If you have an application out there which is, say, using USB 2.0 right now, and you do want to adopt USB Type-C, you do not need even the high-speed USB or USB 3.1 support. You do not want alternate mode. You do not want power delivery. You just want to get into the Type-C ecosystem. And then this is a very simple solution here. You can still use the CC logic device because you still need to do the identification of which side is going to be what based on the CC lines. You have to flag the pull-ups and pull-downs appropriately. So you need that CC logic device. Again, you can use load switches for your port protection and just simple ESD. And as you can see, the key thing to note here is there are no data switches involved. And it's important to understand this because if you remember the pinout, USB 2.0 lanes were in the middle. So even when you flip the connector, they're not going to get swapped. They're going to stay in the middle, the differential pair. So there is no need for data switches when you're just using Type-C connector for USB 2.0 data transfer. So hopefully this gives you a good idea about how to build a system with USB Type-C with different use cases. We just captured use cases that supports power delivery and alternate mode, that supports only the high-speed USB without the power delivery, and also the simplest use case where you are only basically imitating USB 2.0 functionality or using Type-C connector or Type-C. So moving on, let's look at very quickly some of the details about the NXP solutions relevant to this. So as I mentioned, NXP offers both the full PD5, which is applicable for systems that want to implement power delivery, and also a simple CC logic device for systems that do not want to use power delivery. So the PTN 5100 is the PD5 for a full-blown application, and PTN 5150 is a CC logic device that is, again, only targeted for applications that do not want to support power delivery. I'm going to just cover the high-level overview of all the different NXP solutions without going into too much detail in view of time right now. So this, again, just shows you a simple example of how you can make a simple USB system using a CC logic device and still get the benefits of the Type-C ecosystem. Let's quickly look at the data switches. So again, I mentioned and you saw that depending on the different applications or features you want to support, you may want to use a different kind of data switch. So here on the top left is the CBTL 02043, which is a very simple 2-to-1 USB 3.1 switch. It is extremely high performance and high bandwidth, so already capable of switching USB 3.1 signals, but it is just a 2-to-1 switch, which means very applicable for solutions, for designs that only want to support USB 3.1. We also have an active USB 3.1 switch, so if you do want to add the redriver capability, then you may want to use an active switch. And the other two switches, the switch that I've shown in the middle and to the right, are different flavors of a cross-point switch. So if you are developing a system that does support alternate mode, along with the high-speed USB path, then you would need a cross-point switch, as I discussed earlier. And we have a couple of different options to talk about the cross-point to offer solutions for high-speed data switching as well. Now, when you are supporting alternate mode, you need to take care of the sideband signals as well. And NXP has a portfolio of analog switches targeted for sideband signal switching as well. So when it comes to the data path, we have solutions for high-speed path as well as for the sideband signals. Now, looking at signal integrity solutions, again, just a quick overview of the different redriver solutions that NXP has. We have solutions for a single port, single channel, and dual port, all available, targeted for different use cases and different applications. Now, as you all know, NXP also has a big portfolio of microcontrollers, and the beauty of this architecture is that you can pair the PD5 with any MCU that you want. And what I mean by that is your MCU can not only handle the task of running the PD firmware and managing the system policy for power delivery, but also take care of your housekeeping functions that your system may need. So this just shows a quick example of how the PTN 5100 can be paired with NXP LPC series MCUs to target different configurations and come up with an optimum solution. So you can pick a different micro, for example, for notebook applications, for portable applications, and a different micro for a simple dongle design or a more simpler use cases. So this just gives you an idea of different MCUs that we have and how they can be paired with PTN 5100, which is the PD5. This talks about the load switch applications. So again, to explain in a little bit more detail, I'm showing two power paths here, one going into the battery or your charger or your main power path into your device. And again, VBus can go up to 20 volt 5 amps. So we have load switches capable of switching up to 20 volts with OVP and OCP features built in, and also another load switch I'm showing here for the reverse use case. So imagine like an OTG type of functionality where you need to actually put out 5 volt 3 amps, up to 5 volt 3 amps. Then you need like a 5 volt switching load switch, which is still over voltage tolerant up to more than 20 volts. Because that's what the VBus can go up to. So several load switch options as well to meet different system requirements. And one of the last system solutions I'm going to talk about is a charger device. So as you can see, with the Type-C connector being adopted across a lot of different types of devices across different verticals, the chargers, the AC/DC chargers are also moving towards adopting the Type-C connector. And NXP already had a very strong portfolio of the AC/DC front-end devices with our TEA family. So now we can offer a complete, simple solution to make a PD or power delivery capable AC/DC charger with 3 chips, as I've shown here. So you have the primary controller, you have the synchronous rectifier, and you have an integrated secondary side PD controller targeted for AC/DC applications. So if you are looking for an AC/DC application, you can look at our TEA family of devices to be able to design your system. And finally, all the ESD protection. and the EMI filtering. So as you would be familiar, NXP has a very strong and broad portfolio for offering filtering, common mode filters, and ESD protection solutions. So we have developed some very targeted solutions around USB 3.1 and Type-C for your design. So with that, that gives you a very good overview of all the different blocks that are needed in a Type-C design and NXP solutions for that. This gives you an idea of all the NXP devices, relevant to Type-C design. So I have segmented them as the high-speed switches, analog switches, redrivers, the PD5 and the CC logic device, the load switches, again, AC-DC adapters, solutions for microcontrollers, and finally, MOSFETs and ESD protection. So that is the comprehensive NXP portfolio for designing any kind of Type-C ecosystem or design across any of these different vertical segments that we talked about. And so that brings me to pretty much the last slide I have. What is the NXP benefit and what is the value proposition of NXP solutions? So as you can see, we offer a complete solution to design a Type-C based system. We have the CC logic and PD5. We have the MCUs, again, the load switches, and the discretes. And if you want to add even authentication and make your design even more secure, NXP is one of the leaders when it comes to security and authentication as well. So we have done this design in-house. So we have a system, that works with all these different parts who are coming together, and it's really a one-stop shop for your overall system design, no matter what configuration you want to support. And so finally, USB Type-C really ties in the vision of seamless connectivity of data, video, power. And with NXP solutions, you can add security with it as well. And now you have a single connector with which you can take the benefits of all these different functionalities. So that is the end of my presentation. Hopefully that was helpful. And now we can open it up to some questions.
All right, thanks, Ravi. Now, before we begin with today's Q&A, please go ahead and fill out the feedback form that's opened up on your computer. To complete the form, please press the Submit Answer button at the bottom of the page. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're now going to move on to the question and answer section of the presentation. As a reminder to go ahead and ask a question, just type your question into the text box located below the media player, then click the Submit Question button. Please note that we'll try to get to as many questions as we can in the time that we have left, but if we do not get to your question today, someone will get back to you via email. So let's move on now with our first question. Looks like our first question for you here. How do I enable HDMI through Type-C?
So thanks, Chris. As I mentioned, under alternate mode, you can have DisplayPort data going through the Type-C connector. So a very popular way to enable HDMI is to use a DP to HDMI converter chip or a bridge chip. And so you can make a Type-C to HDMI dongle if it's an external application, or you can just use a DisplayPort to HDMI converter chip because the alternate mode is going to allow DisplayPort signals, so you will need to have a mechanism to convert from DisplayPort to HDMI. So thank you for that question. Another question, very quickly I'll answer, is probably applicable to everyone. There's a question about the slides. Yes, the slides will be available to you. Please send me an email. I think that would be the best way to get a hold of the slides. Please send me an email, and I'll be happy to forward you the slides. My email, if you haven't noted down, is my first name, Ravi, R-A-V-I, dot last name, S-H-A-H, at nxp.com. So feel free to send me an email with any other questions or slides if you want. Another question. There's a question about the power profiles that I mentioned, and it says, it seems to imply that you can have a 5-volt 2-amp in addition to the 20-volt 5 amps. Is that really the case? Because that would mean you are delivering up to 110 watts. So no, that is not true. I am not sure why that appeared through my profile description, but to make it very clear, the ceiling is 100 watts, which is 20 volts, 5 amps. So no matter what profile you choose, it has to be under 100 watts. That is the limit of the standard and the way it has been designed. Another question is, an application requires more than 5 volts. It, however, does not need any scalable charging. Does it still need to support full PD? So the answer is yes. So say if you have an application that requires fixed 7 volts, let's just make a number which is higher than 5 volts. Now the question here, it seems like, is that I'm always going to ask for 7 volts. Why do I need the whole PD stack to be able to negotiate power? The answer is you still need the PD stack because the way the spec is defined, partly the definition and to be more secure, when two sides plug in over Type-C, you always come up at 5 volts, and that's how the handshaking is designed to be. And that also makes sense because you don't know what is the capability of the other side. So you always start up at 5 volts, and then if you want, say, 7 volts or anything more than 5 volts, you send an explicit message to the source side saying, hey, can I get this particular profile? And to be able to do that, you need the ability to send those PD messaging, which means you need to have the PD-PHY and the MCU. So yes, you do need to support the full PD if you want to support higher than 5 volts. Another question I see is a nice question. What benefits do you see of a separate PD-PHY and MCU? So it's a great question. So I'll give you a couple of thought points regarding this particular architecture. So first thing is the PD-PHY, especially the NXP PD-PHY that we have, since it is separate from the MCU, we can design it to be a high power device. And what I mean by that is we have integrated several features that are necessary into the PD-PHY, like VCON switch. So one of the things in the spec details, again, is that whoever is the power provider needs to put out 5 volts on the VCON pin. NXP solution integrates the VCON switch, and it also integrates the LDO, which is necessary for a dead battery situation. So imagine if you have an application that supports power delivery, but it is battery operated. And if it's in a dead battery situation, you need some sort of a design which is going to wake up your PD-PHY and MCU and then do the power negotiation. So in summary, my message is that the PD-PHY solution we have, it is very integrated, and hence it would not require a lot of discretes that would be otherwise required around the chip to be able to interface directly with the V-bus, which can go up to 20 volts, drive VCON. Because if it's a MCU device, an MCU pretty much cannot directly drive out 5 volts at 1 amp or half amp type of power. So having a separate PD-PHY and MCU really makes it a very clean design because now you can have a very integrated PD-PHY with hardly any discretes around it, and a separate MCU which can also be very scalable now, which means you are free to choose your MCU based on the resources that you need for your system. So you can have an MCU that is not only running a PD firmware, but also running your housekeeping functionality. So it's a very modular and a very scalable design when you have a separate PD-PHY and MCU. Another thought point is when you have a multi-port design. So think of a design where you can have more than one USB port. And in that case, again, with the separate PHY and MCU, you can envision just one PD-PHY sitting at each port, but you can have one MCU, which is a system policy manager for both the ports, or even more than 2 ports, how many ever number of ports you have. So again, in case of a multi-Type-C port implementation, definitely you will see some benefits of a separate PD-PHY and a separate MCU because it will be a very scalable solution. Let's see, it says, there is another question. It says, is a separate microcontroller essential? Can the host CPU and software control the PD-PHY and other Type-C attachment or requirements? So the answer to that is you need to have the PD firmware, which is very much driven by the standard. So typically, say NXP already has that firmware developed, tested, and working with very good interop results. So if you want to develop your own firmware, you can probably do so, but obviously it is a very involved process, and then you need to tie in it with your CPU and processor and make sure you have enough resource on that available to run that PD firmware. Let's see, we have a couple more minutes. Maybe I can take one more question. So this is a good question around the cable. There's a question around the cable. It says, what kind of cables are used for USB Type-C? So there are two types of cable in general. So there is something called an electronically marked cable, again, as defined by the spec. And if you want to support higher current or data rate through the cable, then to make sure that you are using a certain gauge or it's a good quality cable, the spec is written such that you need to put in an electronic marker IC inside the cable, which essentially just announces to the host that I am so and so cable, and this is my capability in terms of carrying this high current or this data rate, so that the host can put out that high current without damaging or creating any problems. As far as the thickness and the length of the cables, I think all that is part of the spec. So if you refer to the spec, there are all the details around the Type-C cable given in the spec. So I think we had some really good questions. Thank you for your questions, and thank you for your time for dialing in and joining the webinar today. If you have any more questions, feel free to send me an email. Again, my name is Ravi Shah, and my email is ravi.shah@nxp.com. And thank you very much for your time. Chris?
All right. Thank you, Ravi. Great job on the Q&A. Great job on the presentation. And for more information related to today's webinar, please visit any of the resources links open before you. Again, if we didn't get to your question today, someone will get back to you via email. Within the next 24 to 48 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Additionally, you can view today's event on demand by visiting www.techonline.com. Once again, we'd like to thank you for attending today's webinar, Enabling Seamless Connectivity with NXP USB Type-C Connector Solutions, brought to you by NXP Semiconductors, Tech Online, and broadcast by UBM. This webinar is copyright 2015 by UBM. The presentation materials are owned by or copyrighted, if that is the case, by NXP Semiconductors and Tech Online, who are solely responsible for its content. The individual speaker is solely responsible for his content and opinions. On behalf of our guests, Ravi S. Shah and NXP Semiconductors, I'm Chris Keach. We'd like to thank you for joining us, and we hope you have a great day.